Welcome to AI Month 2023. My name is Petra Vorsteher and I'm co-founder of AI Hamburg, and I have the great pleasure to welcome you to an exciting day with 7 amazing panels and 23 expert speakers. I hope, of course, you will join us for all of them. Our first session is Quantum Computing, the Future of AI. I will pass it now to our moderator, Ingo Hoffmann, who will introduce our panelists to you. Thank you.
Thank you, Petra, and welcome everyone to this first webinar of this really interesting day. We are starting with not just one, but really 2 of the hottest topics in technology: quantum computing and artificial intelligence. And I'm very happy to have 2 experts with me to discuss this topic. Anisa Rizvanolli from the Fraunhofer Center of Maritime Logistics and Services, and Steffen Maas, who is an entrepreneur and expert on quantum and AI. Welcome.
Welcome, Ingo.
Thank you. Welcome. Hello from my side.
So to get started, Anisa, maybe you can give us a little background on your activities and what you are doing at the Fraunhofer Center.
Yes, of course. Well, we at Fraunhofer Center for Maritime Logistics and Services do a lot of applied research, which is also the main aim of Fraunhofer, to bring everything that is done theoretical at the universities, the latest innovation, to bring them to the German and European industry nowadays. And at CML, we are focusing on maritime logistics, on shipping, on ports and hinterlands, on their main challenges like scheduling, route planning, time slots, managing time slots in ports. And we're trying to model and invent or develop methods and algorithms to solve them in a more efficient way nowadays. My team, the team that I'm leading, is basically doing this. So they are trying to formalize the problems that arise in the real world and find efficient algorithm to solve them within a reasonable time. Because most of the problems, mathematicians would say, are NP hard, which means they cannot be solved within a reasonable time with the resources that we have nowadays.
Very good, thank you. And then we'll come back to that in more details later for sure. Yes. Steffen, so maybe a little bit about your background as an entrepreneur and AI and quantum expert, and what you have done so far.
Yeah, sure. So my background is I'm from business informatics, and I was working for 15 years in the consulting industry. So I was digitizing a lot of industries, and I founded Ginkgo Analytics 5 years or 6 years ago, where we have used AI as a service, or provided as a service, to really solve problems in companies and build customer-specific solutions. On top of that, we have introduced the Quantum Lab in summer last year, where we have really combined the expertise from 3 different companies to put more emphasis on bringing quantum into real life. So that means we have developed concepts or frameworks how you can leverage quantum and identify the good and promising use cases. And we have implemented prototypes on the hyperscalers, so on IBM and Amazon and Google, to really show that this is not something which is far away in the future, but which can be used right away. So I'm currently in a short break because I've stepped down from managing as a managing director and are now moving into the entrepreneurship. So I would like to promote this topic of AI and quantum further, and maybe go new ways which have not been done before. But it's
that sounds good.
Passionate topic for me, and I'm happy to have a short break from the break.
Thank you very much. Wonderful. So what we plan to do is talk a little bit about well, AI and quantum, obviously, both from the research and more from the applied side. And I think that's why we have you two here in the panel. And really starting with well, basically the question that maybe some of the audience have: what is quantum computing, and why is it interesting for AI? So Anisa, maybe you can give us in simple terms what is quantum computing, if that is possible.
Yeah, this is a hard question, and you know what it makes it hard. This simple terms, because classical computers. But I will give it a try. So classical computers perform calculation by encoding information as digital bits. Most of you know 0 or 1, and the computer might flip a voltage in a circuit. This has been done like in the 60s to decode or to create this 0 and 1. Quantum computer has as physical base the subatomic world, not this voltage moving from 0 to 1, but which, like for example, subatomic world, you can think about it like electrons moving in an atom, and you want to measure where they are. And this world is ruled by the laws of quantum physics, which is not very intuitive for us to grasp it. And but the main the main idea behind that is that the electrons, before you measure them, they exist in a probability world. So they have a probability of being 0 or 1 or being the same, both in the same time. And this makes a quantum computer quite interesting for all of these problems that I mentioned before that are not solvable within a reasonable time. Because you can imagine if you have this probabilities and being able to have many states on the same time, or just to calculate them in the same time, you can do shortcuts in the search space. So if a normal computer would search the space 1 by 1, 1 million, let me say 1 million points to check out and to see which is the best one, a quantum computer could do like 1,000 in a step. This is the theoretical part, and this is what I am trying to explain in simple terms to see the difference between a quantum computer and a classical computer. So qubits, when they are built in an adequate way, can have that magic state of superposition, so live as probability of solutions, and we can make advantage of it in the sense that we can run bigger problems that could not be run within a reasonable time nowadays. I hope it was clear enough, but if there are questions, I'm happy to answer them.
Thank you. I know it's a tough one. And by the way, if there are questions from the audience, feel free to put them in the chat. So we'll see that we can answer them either in the discussion or at the end. We'll have some time for the questions reserved. Steffen, so you have seen that, and you have looked at that from more the industry point of view. How do you see quantum computing, and how will that development impact AI from a practical point of view?
Yeah, I had a look at quantum, and it really hit me when I understood that quantum is the next generation of computing. So currently the classical transistors are coming to an end where we cannot make it any smaller and faster. So this is something which will come definitely. And it's not something like a hype or something like that. It will definitely transform the way how we deal with computers and how we compute. And we are only touching the beginning of what we can do with it. And I think this is something which is really interesting, and where I think it's definitely worth exploring it further, because it will definitely have a very high disruptive potential of disrupting the industries. When it comes to quantum and AI, what I think is really fascinating is that, as Anisa said, it can solve specific problems much faster and in a much more clever way than classical algorithms. And I think when we look at the capabilities of quantum machine learning, there are different fields where also today there are already available capabilities which you can use. For example, if you want to search for something and you can have an immediate result without calculating for days or weeks or months or years, it will definitely have a huge potential to disrupt something. So I see that it's definitely something where companies have to have a look at, and most of the companies don't have the capacity or the understanding. So I have the impression we are in a similar situation as AI 10 years ago. So everybody was like talking about it, wondering about it, like what is it, what can it do, and wondering how do I get started. And I have the same impression as before, that we need to do a lot of education, a lot of showing, proving that it's already there and that it can be used and that you can really leverage the potential in short.
Maybe from my sorry. So maybe just a comment to the part with quantum and AI. I talked about this superposition, and if you have many qubits, then you can run and skip some search space, so it's faster. You can imagine this part helping in machine learning when you train your data. When you train the data, the computer does nothing more than just optimization. So it searches for the best solution among a huge amount of different, in a huge search space. And if you are able to help this algorithm in the deep part of the training model, then you can be much more faster. So this is one aspect where it can help. So in training the data, the next one, as far as I know from all the AI experts, you have a lot of parameterization, and you have a lot of biases and parameter to set in dependence of your question that you want to solve. And there you have also the same problem of having too much data and large search space. And these are the two technical points where quantum could help AI. Basically, quantum helps in solving optimization problems, and optimization problems are in AI. Even if the normal discussions is going like model-based or database, they're basically the same. So you have the same mathematics behind that, and you have the same challenge.
That's a very good point. So maybe one question, or going one step back, Anisa, we know that quantum computing, we have seen first quantum computers, right? But they are still kind of in the very early stages. Steffen mentioned maybe 10 or 15 years ago. Deep learning was also very, very early, very limited. I think we'll probably have a similar situation with quantum computing today. So where are we with that, and what is it that you see, especially in your area of maritime logistics, where this already can be applied, and how do you approach that?
Well, the universal getter-based quantum computers, so the guys that would be analogs to our classical computers, where you can run any kind of problem and program them down, they're a little bit far away. So we are like 100 qubits with IBM, and their roadmap looks very good, but they have some challenges at the physical state. So it's not set right now which of the physical implementation would be the best one in order to get the error correction into limits and so on. So they are far away from solving the problems that I meant at the beginning of the session. So like if you have 500 people or like 500 ships and you want to schedule 14,000 seafarers for the whole year, that cannot be done with a universal quantum computer right now. But there are some technologies in between called annealer, like the quantum annealer or quantum inspired. This is how Fujitsu calls their digital annealer. They are specialized hardware that can solve very fast only some kind of problem, some kind of optimization problem. So the question is there whether my problem can be put into that special form so that I can make advantage of that special hardware that solves only, they say, quadratic, unconstrained, binary only optimization. So you have to have a quadratic objective function and no constraints so that this hardware makes sense. And we are working on that right now. So we are modeling our some of our optimization problems as qubits, put them into D-Wave is one of the well-known quantum annealer manufacturer, and do some benchmark with the classical part with guys like Cplex and Gurobi. So these are the classical commercial solvers for optimization problems. And it's a long way to go. And basically the first step doesn't have so much to do with the quantum itself. The first step is formalizing the problems. So getting them from the, I don't know, from the mines or from the not digitalized systems of shipping companies or ports or other maritime logistics players into a formalized way, into a structured way, and then using either classical, hybrid, or quantum computer to solve them. And we are in that first step, investing a lot in that first step. We have a lot of experience. I'm doing it since 10 years now, this all kind of formalization, but it's a long way to go. And I think there is the first step that you anyhow have to do. And as soon as you begin with that as an industry partner, as better it will be. So you cannot start with that when the quantum computer will have their stable 100 qubits, then it's too late.
So I understand that basically you cannot just transfer what we have today and put it on a quantum computer, obviously. So you need to really, first have very, let's say, specific challenges that are really good for quantum computing. And then you need to formalize that to have a new way of programming, so to say, for the quantum computers. Steffen, how do you see that in the industry? I mean, where are industries that already are looking at that, and what are these challenges that they are looking at that are actually good for quantum computing?
Yeah, first of all, I think to add to Anisa, what we also have seen is the hybrid thing. So not taking a complete problem and trying to solve it in quantum, but rather breaking it down into several steps and then making one of these steps a quantum algorithm or solve it with quantum. And then if you follow it, afterwards you use the classical approach. So I think that is an approach which can be used right away. And I see that there are different problems in different industries. So we have worked with different industries, and for example, I personally see a very high impact in the financial industry, where, for example, also the problem of security, it's an industry-wide problem where you can break encryption, where you can break blockchain. So if you're invested in blockchain, be careful, but also the complete finance industry optimization problems. Yeah, so optimizing a portfolio, an investment portfolio, trading in real time is something which is really perfectly usable for quantum computing, because you can calculate all the different opportunities, what you can buy or what you can sell in real time at the same time, and you can optimize it. Of course, for that you need a lot of parameters, because you have a lot of options what you can do, and this is the limitation which you currently have in the quantum hardware. So if you have more computing power, you could solve financial problems immediately. But also when it comes to insurance companies, for example, what you can also do with quantum is you can simulate environments. So you could simulate a specific behavior of people. You can simulate weather forecasts. You can make that much more or much better than today, and you can work with that. Also, a big impact I see is on the chemical and manufacturing or let's say material science industry, where you can simulate the behavior of atoms and molecules or even material. So that's something which is currently already used, where partnerships are being developed or have been done between larger industry players like Bosch and IBM, where they are working together on making things better. For example, developing new batteries, making them much more efficient and so on. So that's something which is already there and which is having an impact. But I also think, for example, pharma and life science is an industry which is really perfectly usable for quantum, because currently you have a lot of effort going into developing the right drugs, developing the right candidates. It takes years until you have a medicine which can cure something. And if you can speed this up with the help of quantum, you can have a really good impact on the whole industry and also on the society in itself, because you can solve flus in weeks instead of months or years. But also when it comes to personalized medicine, I think it's perfectly usable, because you can directly develop drugs for a specific person instead of a group of persons, which then has something. And I think we have a talk later this day about the whole topic of medicine. I also think huge impact is possible in the energy business. So solving the energy transformation from classical to more environmental friendly energy is something which needs to be more decentralized, which needs to be more flexible, because you have different sources of power, you have different demands, you have different supplies, and to balance it and optimizing this in real time is also something which can be used with quantum, where you can have the different parameters and optimize it in a way. And of course, as Anisa said, the logistics industry is a perfect example, because you can optimize so many things, and it can have a real good impact. And this is what I think is the good thing about it. When you solve the optimization problems, first you can save money, and secondly you can reduce your carbon footprint. Or your footprint on this environment. We have the Earth Day today, so it's a good thing where we all need to take care about, and where we need to optimize the way how we deal with anything. And when it comes to logistics, I think it's covering the whole range from optimizing a network to optimizing a fleet to optimizing the last mile, where you have so many parameters like ships or cars or people or birds, so we have all the different parameters which need to come into place, and where classical computers are really at their edge, where they cannot compute more, or where they need much more computing power or much more time. So that's in a nutshell. I think there are a lot of more opportunities where you could start.
Absolutely, and I think that shows the potential clearly that we have here. Now on the other side, and Anisa, you mentioned some of the challenges already, and maybe we take that topic of logistics, and can you talk a little bit about how do you approach that today? I mean, what are some of these challenges we face, and how do you approach that in your work? What are some of the skills that you need today to really get into the operations, so to say?
Yeah, of course. One of the main points, if you want to develop something in the maritime logistics, especially in shipping, is the domain knowledge. So we will all say, okay, route planning is everywhere and needed, but still they have their quite specific requirements that you need to know. You need to have some experience, to maybe have been by yourself on a ship and run and did the route planning with them, to understand which are these conflicting constraints that you need still to take into account, even they are conflicting. And that's the main part, which doesn't have to do with any special knowledge, just domain knowledge is important to get the problems, to understand the problems in the right way and to model them in the right way, because you cannot help the industry by putting a theoretical model that works perfectly on a computer, but it doesn't take care of the requirements that they have in everyday life. And the second part, when doing all this mathematical stuff and now quantum computing, is of course it's good to have some background background in mathematics, computer science, physics. Nowadays, quantum computers are not so far that they are built like our computers, where everything is abstracted. So I'm as a user, I don't have to know what does the assembler do or the physical layer, because the quantum computer is not there. So I'm very happy to have some colleagues that do quantum physics, so I can ask them for the layer between, because as a user right now, and the way they are being programmed is still like this low level. It's a combination of high and low level language. So you need this collaboration of many different people from the domain, from the computer science part and from the physics part. I think this will disappear in the next 10 years. Many people are working on developing high-level languages, and IBM have their own frameworks, and they are building frameworks of frameworks. So we are moving toward what we know as a normal, as a classical, from the classical computer, that we then have just like something like Python and high-level languages. So, but right now we are at the state where we need this close collaboration of all these experts to really get good models for the industry, and to get them work, or to make some proof of concept on the different hardware that is existing right now. It's not so easy. And what we are doing right now is modeling what we call the maritime inventory routing problem. You can imagine it as a problem of a tanker shipping company. The use case comes also from a tanker shipping company here in Hamburg that moves their tanker ships between some ports that produce some chemicals and some others that consume them. You can think about it as the LNG problem right now, which is modern. You have to produce and consumer, and you want to build the network in such a way that all the capacities and requirements in the ports are compliant. You are compliant with them, but you don't want the ship to get many idle days, so many days waiting for the next job. And this is the specific problem we are modeling that I mentioned before, and we are benchmarking it against the classical solutions and try to find some specific heuristic that gets advantages of the properties of the problem. And there it comes. That this makes a difference between doing it in a general way for every routing problem and doing it specific for this routing problem. So you have to put the knowledge that you have, the background knowledge, into the solution, and this makes it faster, even in a classical way. And for quantum computing, it will be the same. Mm-hmm. Mm-hmm. Yeah.
So Steffen, as an entrepreneur, what's your view on that? I mean, you mentioned earlier that this is something you really are interested in and you're looking at. What do you see there? I mean, are there startups out there, and what is happening towards quantum and AI from an entrepreneurial perspective?
Yeah, from an entrepreneur perspective, I do see some startups, and I do see some movement in this area, but it's definitely not enough. Yeah, so when we have a look at startups, what I see is a lot of hardware startups which are focusing on one specific technology, which is good and which is definitely required to have this knowledge in Germany or even in Europe. But on the same side, I also see the demand to have startups really focusing on one specific problem and solving it, because I've seen the struggle for companies to get resources and infrastructure on board for AI itself. And quantum is even one step more specific. We have different frameworks, we have different programming languages. Do you use Circ or Qiskit or whatever? So it's really difficult to get this knowledge into the own company. And I think for the future, it's much more useful or handy if you can buy solutions on the market which can be used as plug and play in my IT environment. Yeah, so I do see the demand for more companies which do take the risk, which solve a problem and say, here, Maritime company, you can buy the optimizer and use it as a service. Yeah, and then you can implement it via plug and play. So I do see that in a lot of areas, especially when it comes to small and medium-sized enterprises. I don't think any small and medium-sized enterprise will have a quantum team. It will not come in the next years. So it's definitely worth providing solutions to these companies in a ready-made step. And I think what will come in the future is that also the large hyperscalers, which are currently providing already the infrastructure as a service, will also come to a level where they provide solutions as a service, where they say, okay, we have specific problems which we see at different customers, and if the portfolio is large enough, then of course for them it's also interesting to develop something to provide it as a service where you can really just send the data or send the requests, and then you get an optimization in seconds. But I think it's definitely a great space going further. And for the larger companies, I also think, of course, you can have your own team, but I think it's also worth looking into co-development options, that you really combine the knowledge and expertise you have already in startups, in academia, in consultancies, for example, in Fraunhofer, that you combine these into teams which are working on one solution. And then if you want to do this, you can build your own entity around it and say, this is something where people work together to solve one problem, and go. And then provide it to the market and also earn money with this. Yeah, so you can provide new revenue streams and develop solutions which you also provide to others, not just to your own company. And I think that's a very interesting field, especially if you have a solution which really solves a problem which nobody else has solved before, and where you have a competitive advantage for at least 1 or 2 years.
Yeah, absolutely. And so, Anisa, I understand that you are working with some of the corporates that already are starting with quantum and AI. So how do you see that? I mean, I assume these are mostly larger organizations. How do we work with them? And also, are there some best practices how that really works in real life?
Well, yeah, we are working with them, and there are larger ones. I see that Steffen mentioned with the smaller ones, it's difficult. So Fraunhofer is either doing specialized algorithm development for one company, and they have their specialized stuff, or we are working together in larger research projects that can be funded either by the German government or by the EU funding, or we get EU funding. And this is also a good way to go forward and to invest in such early step technology, where you don't really want to throw your money out for something that is very not really clear right now if you really need it, or if you should invest in that. And this large scale or governmental founded projects, we have one from the state of Hamburg, where we are looking for the various use cases. One of them is this maritime inventory routing problem. And I mean, we would like to have more, if there is somebody out there that would like to test a specific use case from the maritime logistics, we would be happy to share our knowledge and our achievements. That's what Fraunhofer is for, basically, to help the industry and to test some use cases. So you need to come with a use case. There must be a willingness from the company side to invest in resources to describe the use cases, to make sure what they want to solve. And after that, you get the next step where you don't really have the resources. You get them done in such kind of cooperations, either with Fraunhofer or with universities or other partners like DLR or whoever. They do applied research in Germany, but mostly Fraunhofer.
Yeah. Absolutely, and I think that's especially given that it's still very early in the development of quantum and AI. I think that's a very good approach. Steffen, any other ideas on how to get started? And I understand that this can be quite disruptive for many industries, probably a few years down the road. So what should you do today, and where can you start, and where's the money then coming from that you probably also need to get started?
Yeah, I think I think we need a bit more clearer roadmap on that. So before jumping into specific implementations, I think we need a much more awareness about the topic. So things around forums like today, but also a lot of education, like explaining what it can really do to then develop use cases, because this is something we have done in the past or we have experienced. You need to have an understanding about the quantum capabilities. And then I'm not talking about algorithms or physical states. It's more the abstraction layer on top to really understand what can I do with it. Yeah, I can search, I can optimize my sampling if I pull out a specific targets from a group. I can simulate things, and then transfer this capability into something where I can say, okay, I have a problem in a specific field and I can apply it. And this is then the use case. And once you have that, then you can go into implementing a pilot or a lighthouse use case where you can then show that this is really doable and where you can learn how you can do it, what you need to do. And that, I think for the funding, of course, the easiest is to use one of the funding pots, let's say, which you have. So there's a lot of funding initiated from the German government. I think they are about to spend 3 billion until 2026. A lot of this goes into hardware, but I also saw some calls which are really dealing with the application of quantum algorithms in real life, let's say, or in the business world. And there are also calls which are dealing with building companies out of academia, out of prototypes, to really leverage this knowledge and things we have. And I think that's something we need to take care about in Germany, because in Germany we're very strong in the foundation and developing everything which you need to do it, but really getting it into production, getting businesses running. This is something where we really need to have our finger on and say, this is what we want to do. We want to have companies which are leading edge, which are using the latest technology and which are able to scale globally. And I think that's something where we really need to take care about a bit.
Yeah, fully agree. I think we've seen that before, not really working well. So hopefully this time we'll do a better job there. I'm totally with you. So looking at the time, and then also talking a little bit about where this is going and the future. And there's one question in the chat asking about the availability of the qubits and the stability, and where is this going? So basically, I think the question is the quantum computing that we have today as a hardware is still, as we discussed, relatively early and not in a position to for example, handle all the error corrections on scale. But I think we see there is developments. Where are we, and what do you expect for the next couple of years, Anisa?
The next hard question.
Sorry for that.
Yeah. Well, I'm used to it, but yeah, it's difficult, because if you see the roadmap of the big players like IBM or Google and so on, and Microsoft also, they are telling something about the 1,000 qubit limit to be reached into the next 5 years, but they are keeping very poor information on their error correction. What does it mean? But if I only have 50 qubits and use 40 of them for error correction, then I only have 10 to calculate. That's not so much. So that's still open. Just also because the race is still open for the different hardware implementations. So they are looking, and that's why Germany is also now spending a lot of money to be able to get them all implemented and be sure that they benchmark it by themselves. That superconducting, maybe it's better than cryogenic or whatever. I'm not a physicist. I just know that superconducting qubits is the hype right now. But if it will be the next 2 years, I'm not sure. Or maybe topological qubits would get the breakthrough. So yeah, right now it's a big problem that they are very fragile, so that you have to shield them, that you have to cool them really down in order to get the superposition in life. And as soon as they interact with other systems, they fall into 0 or 1, and you lose your calculations. I have seen that Fraunhofer has a exclusive access to the IBM computer in Enningen and some other IBM machines with IP protected. This is another issue, as Steffen mentioned. And yes, it's you have to have a lot of time to calculate there, and you have to live with the fact that now it's not really stable at the moment, but I think it will change. So there are all this investment from the companies and governments will bring speed up, but we have to live with that.
Yeah,
you're welcome.
Very good. I know it's a different question. So maybe to close, we started the panel with the question, quantum computing, the future for AI. So Steffen, what's your view? Simple answer to a difficult question.
Definitely. It's the future. But I think important to understand is that quantum and AI does not solve all the challenges. So we will not have a large language model in quantum or a generative AI in quantum. But as Anisa said, if you have a specific problem, like an optimization problem, I think quantum is definitely the future to solve these problems. And I also see in the future that the access to quantum and AI, so especially the quantum machine learning as a intersection between these two worlds will be much more easier. So yes, the hardware race is on, and yes, there are problems to solve, but also there are companies which are working on a layer in between, on a virtualization layer, where you don't need to care about this. And I think this is a development which I really like, because I don't want to take care about the details, and I'm happy if there are experts who are dealing with that. But for example, also IBM is working on an integrated error correction on the algorithm level. So they do this magic in the background, and you don't need to take care about it. And also the access to these algorithms, which will be much more easier. So you don't have to manually program any gates or so on. So you have a complete algorithm which solves a specific problem where you put in some data, you get some data out, and you don't need to take care about it. That's a development and a trend I see, which is really favorable to see these algorithms then in practice and in reality.
Perfect. So I understand, yes, it's the future, not for all of AI, but certainly for the parts where there's a good fit. And Anisa, your view?
It's more or less the same. I mean, I'm happy that I live in these times. So I missed the first steps of the computer as a computer scientist. Now I'm living the first steps of the quantum computer. The history is a little bit repeating itself, like being very big and not being able to do anything. But then in a few years we move forward and see all these developments, all the stack evolving, as Steffen mentioned. And I'm quite positive that it will work. So maybe we will have also some applications that we don't have in mind right now, but then it opens up when it works, like the AI stuff.
Absolutely, it will be really interesting times to come. So with that, thank you very much for the panel and the participation, Anisa, Steffen, and famous last words from Petra.
Yes, thank you very much for this thought-provoking panel. Thank you, Anisa, Steffen, and Ingo. And there's much to look forward to. I'm really excited. And also, I would like the audience to stay on. At 11 o'clock, we have another panel, how the investment management industry is embracing AI-based textual approaches for decision-making. This will also be very interesting. And please stay on. And thank you very much. And have a wonderful day.
Thank you.
Thank you.
Thank you. Bye.
Bye.